Okay, this is Wednesday, April 4th. We're going to do a review the next 3 days of everything that's going to be on your common assessment. The common assessment is like your end of the year exam, but it's 6 weeks early. It's worth a lot of points. You have to show both growth and you have to get a good score on the test. So you're going to have 2 scores, a growth score and a score for the test. There is no retake on this. You have to do well on this test. So my suggestion is you need to watch these videos and really know what you're doing here. So for 3 days you're going to do this, and then when I come back on Monday, we're going to do review on the board, and then that's it. Your test is Tuesday. Common assessment. What have you learned this year? So the common assessment, again, is Tuesday, April 10th. That's when it is. Okay, so this next 3 days is really going to help you, so make sure you're paying attention. So Wednesday, today, we're going to do this first sheet, all graphs, and we're going to do the logarithms, which is the second page. Okay, right here. And then Thursday, you're going to do the trig, which is the third page. And then on Friday, you're going to do the vectors and conics. So this is all we're doing. This packet right here is for the next 3 days. You do not need to turn this in until next week when I get there. But right now, you should be doing this and paying attention. Okay, so what are we going to do? So these first two kind of go together. It says, describe the transformation from p of x to f of x. So you'll notice that this is an x cubed. Okay, it's not asking what the shape is. They're saying what is being done to this. So you can use your calculator. Maybe the calculator will help you, but you shouldn't need a calculator for this. You guys have been doing this for years. This is a vertical stretch by a factor of 4. Anytime that there's a number with the x inside parentheses, we're going to go right, translate right 3, and we're going to go up 1. And then the next two, and by the way, we're done with that problem. So on this one looks, it's a hyperbola. It has the curves, that curve here and a curve down here. This means we're going to go 5 to the left because it's with x. And this 3 is on the outside, so we're going to go 3 down. Use this polynomial. How many zeros does this function have? It has 5 because it's next to the 5th polynomial. Find them all. We're going to find them by setting this equal to 0. And we're going to factor this. But before we do that, we have x to the 5th minus 7x to the 3rd. Oh my God, I can't do this. X to the 5th minus 7x to the 3rd minus 44x. Presume 6. So what you're going to see after you punch this in, are we going to see 5 zeros? I see one that's not a good number. That looks like 0. So I see 3, but there's 5. That means 2 of them are imaginary because these are not double roots. So we're going to have to find these imaginaries by factoring. So what we're going to do is just take a GCF out. And then we're going to factor. So x squared and x squared. The factors of negative 44 that add up to negative 7 are a negative 11 and 4. So these are all equal to 0. So we have x equals 0 is one root. We have x squared minus 11 equals 0, which would be x is plus or minus square root of 11. That's 2 more answers. That's 3 total. Those are your real ones. The square root of 11 is this negative 3 point something and 3 point something. All right, and then your imaginary ones are this third factor. X squared equals negative 4. X is plus or minus radical negative 4, which is plus or minus 2i. And there's your 2 imaginary roots. So you get 3 reals, 2 imaginary. The maxes and mins we cannot see because they look like straight lines. So we have to go to window. I would go to y min, change it to like negative 150. That might be way too much, but I'd rather do this like less time, so make it really big and make sure you can see them. So press trace, and we're going to move this over here to the max. Let's go a little to the left of it. So second trace maximum is 4. See how it says left bound guess down here at the bottom? Press enter. Go to the right of it, press enter, and press enter. So the max is negative 2.39 and 122.74. That's the max. And the min, we're going to find that by pressing trace, moving the spider down. Press second trace, min. It says left bound guess, press enter. Move it to the right, press enter, enter. And that is 2.39, negative 122.74. So it's 2.39, negative 122.74. Good. Identify one interval where it is decreasing. It looks to me like it's increasing here, decreasing here, increasing here. Because you read it left to right. So it looks like it's only decreasing once, so you have to get me this interval. It's from the x of this one, the x of the max, to the x of the min. So we only use x's, never the y's. So it's the x of the max to the x of the min, and that's how you do the interval for it be decreasing. The end behavior, as x goes to the left, that means negative infinity. What does the function do? This function is f of x. So as x goes to the left, the function is decreasing as well. It's going down. And as x approaches positive infinity, the f of x approaches positive infinity. So as x goes to the right, the y goes up. Oops, I just wrote that. As x goes to the right, y goes up. That's how you write it. So those are done. Use this rational function, x minus 2 over x. R of x equals x minus 2 over x. Let's just see what that looks like. Now remember, we just had a weird graph on that last one, so make sure you put parentheses first of all around the numerator. Don't forget the parentheses, you're going to miss this problem. And then I'm going to press zoom 6 because we just went from 150 to negative 150 on that last problem. So it looks like this on a regular screen. You can kind of tell that the vertical asymptote is 0, and it looks to me like the horizontal asymptote is positive 1. But why is that? Vertical asymptotes. So to find the vertical asymptote, you always set the denominator equal to 0. So in this case, the denominator is x, so that's your vertical asymptote. To find the horizontal asymptotes, it has nothing to do with that minus 2 in this problem. I can tell you that. It has nothing to do. It has to do with the highest degree in the x here and the highest degree in the bottom. So what you do is you set y equal to the highest degree of the top by the highest degree of the bottom. Since these are going to cancel, you're going to use their coefficients. So y is equal to 1 is the horizontal asymptote. It's the leading coefficient of this one divided by the leading coefficient of the bottom one. Do you remember what it was if it was something like this? Y equals 3 over x minus 3. This one would have been, if that was your problem, say f of x, not y, your horizontal asymptote would have been 0 because there is no x in the top. So it's smaller in the top than the bottom, and it was just y equals 0. And do you remember what happened if it was something like this? If it's higher degree in the top, it was a slant asymptote. Remember all that good stuff? But let me do one more for you. So if it was 4x over 8x minus 2, let's say something like that, what would the horizontal asymptote have been? So these are the same. So the x's would cancel and it'd be y equals 1/2 because 4/8 is 1/2. These are just extra examples down here. You don't need any of these. These are just extra examples. What value does Rx, that's this whole function, approach as x approaches infinity? So as x approaches infinity, what does Rx approach? So let's look. As x is getting bigger, as x goes to the right forever, as x gets bigger and bigger, what is that y doing? It looks like the y is approaching the asymptote. So it looks like the r of x is approaching 1. Second page. So they give you some compound interest formula and some continuous ones, but these are not even on this sheet. So I don't think you're going to have to worry about those. Maybe you are. I don't know. Maybe on the test you have to. I don't think so, though. So we're going to solve. Write your answer to correct to 3 decimal places. This problem has a single log on the left-hand side, so we're going to solve for x. So first we need to get rid of 6. So the first thing you want to do is get rid of 6. So you have natural log of 4x equals 5. And you can't do anything with the 4 right now because it's in between natural log and x, but you can swoop it by taking base e to the 5th, setting it equal to 4x, and then dividing by 4. So it's e to the 5th. So it's e raised to the 5th power divided by 4. So it looks like 37.103. It says 3 decimal places. Be very careful on the common assessment with directions. If it says 3 decimal places, you have to go 3 decimal places. This one's also a swoop because it's also got a single logarithm. So we're going to take the base 7, raise it to the 2nd, and set it equal to 3x minus 1. So 7 squared is 49. We're going to add 1 and divide by 3. So 50 is 16.667 because it said 3 decimal places. This one's also a swoop. E to the 2nd equals x plus 4. Subtract 4, get e squared minus 4 equals x, and type it in. E to the 2nd minus 4 is 3.389, 3 decimal places. Which of the following is equivalent to this? So when we, this is a single log, and sometimes you have to expand it because you have a lot going on here. So what you do is you count up your factors. I see 2 factors. I see a y and I see an x. So you have 2 logarithms here. So the y squared goes with the first one, and the square root of x goes with the second one. Because you're dividing, do you remember if you put a plus or a minus here? You're hopefully right by saying a minus. Now, another property is that if you have an exponent here, it should be released out front. So it's 2 log y minus. Now this one doesn't have an exponent, but it could, because square root of x can also be written as x to the 1/2, right? So that can come out front as 1/2 log x, and this is b. And the graph of g of x is, okay, the graph of g of x is f of x equals 3 of x. All right, this is one of our graphs, and it says to graph it. So let's just graph it. It's a growth, it's an exponential growth. It should have a point at 0, 1, 1, 3, 2, 9. Looks like I'm right. You can go to your window here. Second window. Go to second window. Start it at 0. Second window. Start it at 0 and go by ones. Second window. Start at 0. Go by ones on your t-table. And now go to your t-table. So there's a 0, 1. There's a 1, 3. And a 2, 9. Now the asymptote is the x-axis, so don't hit it. So it looks something like that. This is f of, and let's label it f of x. Make sure you have arrows. Make sure you have 3 points. It could have been a little smoother, but not bad. Now, that's f of x. F of x is equal to this. Now, g of x, first it says reflected over the x-axis. So if you were just reflecting over the x-axis, let's see if that's right. Negative 3 to the x. Let's see if that looks like it's a reflection over the x-axis. Make sure I got this negative right. All right, that part's right. So you just put a negative on the outside if it's reflected over the x-axis. And then translated 5 units to the left, that goes up here with the x. Translated 5 to the left means we're going to have a plus 5. Let's make sure. So it's going to be the same thing as the red graph, except it's going to go 5 to the left. So let's go and add onto this. If you really want to see if it's a good reflection over the x-axis of this, go up to the first one and make that an x plus 5. Because now the only thing that's different is the reflection. If you really want to know if everything's, so this should be left of the first one that we drew. See, it's left of the first one we drew, 5 left. And then the red one should be a reflection over that, over the x-axis, if I got everything in the right spot. So you should be graphing these and make sure everything's, okay, see how that's a reflection over the x-axis and everything went left 5? So this is my answer for the reflection. Now I have to get it graphed. So I'm going to go back to my graph. I'm going to get rid of this first one. Delete, delete, delete. So this is the one I have. I'm satisfied with my answer, so I need the t-table points. Find some nice numbers. I found some nice. The -5, -1. -4, -3. And -3, -9. So if we would have reflected this first one here, it would have been here, and then you would have went 5 to the left. That makes sense. If you would have reflected this one over the x-axis, 1, 2, 3, and you went 5 to the left, that makes sense. And if you would have reflected this one over the x-axis, it would have been here, and then 5 to the left, and right there. So good. So that's it for this.